Hi there, this is Hugo, and today we'll be having a conference call with two knowledgeable individuals from FHWA. The use of a systems engineering approach is key to a successful project. Today, Tony Whitfield is going to interview Rick Denny, who will be answering questions and giving examples from his experiences to explain why systems engineering approach is key to a successful project.
Hi, I'm Tony Whitfield with the Federal Highway Administration. Today we will be talking with Rick Denny. Rick, can you please introduce yourself?
Sure, Tony. I'm a traffic engineer with 40 years of experience. I started in the Freeway Operations Unit at the Texas Department of Transportation. They managed the traffic signals for the city of Austin and San Antonio. After that, I was a consultant who designed traffic signal and freeway management systems. Finally, I landed at FHWA. My first formal systems engineering training experience followed the emergence of ITS standards back in the early 90s. And I've led systems engineering projects as a consultant and at FHWA ever since. I joined FHWA in 2010. In this role, I provide training, technical assistance, and program support in operations, planning and management, traffic signals, architecture, and systems engineering.
Great, thank you, Rick. You have a lot of great experience, and I'm excited to talk about systems engineering with you today. All right, let's get started with our first question. When did you first learn the importance of the systems engineering approach?
Well, Tony, let me give you a couple of examples. When serving as chair of the National Transportation Communications for ITS Protocol Working Group on field management stations, I observed that practitioners and standards developers could benefit from a common language and consequently work towards the same objectives. That experience helped me realize that systems engineering provides a language for productive collaboration between experts in different disciplines. ITS standards, like systems, are multidisciplinary, and we need that common language. Later, when consulting with a toll authority and a state DOT for what would be jointly operated transportation management systems, we found consensus leading to a productive outcome when we documented their activities and asked each agency to show where they needed to be involved in the other agency's activities. This is much more productive than focusing on the technology feature set as the first action.
That makes sense, Rick. A common language leads to a better understanding of everyone's role and a better final product. Now that we understand the importance of systems engineering, can you give us an example of a successful project that has used the systems engineering approach?
Sure, I'll give you an example. When designing the communications infrastructure for a large multi-jurisdictional traffic signal system, a careful understanding of requirements led us to the application of a relatively simple wireless communications backbone, which we could show fulfilled requirements and met needs. That technology was easier and cheaper to implement, and the agency got a real head start on their larger operational objectives because of it. The communications technology served those needs and fulfilled its original requirements for 20 years, which was twice as long as anyone expected. The total cost of the system was about a third of the cost of similar hardwired systems at the time. The system also used proven technologies for moving video and substantially reduced technological and maintenance risk. The project was innovative, and while we still embrace risk, the risks were aimed at innovative operational strategies rather than using up our capacity for risk just to provide basic background technology.
So being able to trace the system requirements back to well-documented communications needs resulted in a 20-year solution. Very interesting. Thank you for sharing that, Rick. Now, you have had success using the systems engineering approach, and I'm sure you have many examples. But tell us, what could happen if an agency does not use a systems engineering approach on an ITS project?
Here's an example. Let's say that an agency has not followed a systems engineering approach when implementing a statewide, real-time freeway and incident management capability. They have different systems for dynamic message signs, tracking incidents, managing traffic monitoring cameras and video, computer-aided dispatching, as well as collecting traffic performance data, displaying those data in their control centers, and displaying those data in traveler-facing interfaces like 511 call centers. Now they want their freeway management system software to pull all this together, but they do not have system requirements written down so that the system will not be integrated. The lack of systems integration caused extra work, and the users must switch between systems in the control room to manage several communications infrastructures with different system providers. How can you prevent that from happening? One suggestion is, prior to procurement, conduct a stakeholder workshop to identify user needs and priorities, and use this input to develop the document and document systems requirements for the integrated system.
I see. Without that upfront collaborative effort, the final product may never be integrated on the back end. Okay, Rick, you have provided some great insight on the topic of systems engineering, but we have one last question for you. What advice would you give your colleagues who are applying the systems engineering approach for the first time?
First, start with a simple project that implements a technology that is already covered by one of FHWA's model systems engineering documents. Those cover dynamic message signs, closed-circuit television, traffic signal systems, and detection systems. That's low-risk practice. Or if your state provides pre-drafted systems engineering documents for certain classes of project, use those. But don't expect systems engineering, which is project-based, to replace good operations planning, which should already fully document the program objectives and strategies of the stakeholders as the basis for what the project needs to accomplish. If those planning documents don't fully explain the need and application for a project at the strategic level, do the planning first, which is our first principle. Systems engineering becomes unnecessarily difficult when we ask it to perform remedial planning. If you hire systems engineering consultants, include all of the steps of the systems engineering approach in the scope of work, including meetings where documents are demonstrated rather than depending on your own time and ability to review those documents. Consultants can only do what's in their scope. Finally, remember that systems engineering answers only a few important questions. What do the users intend to do? How do they expect the system to support what they do? These questions focus on needs, our second principle. Then, what must the system do to support and enable those activities efficiently and effectively? That question drives requirements, which is the third principle. Then, what products, provider proposals, or alternative designs most clearly fulfill those requirements? How do we demonstrate that the requirements are being fulfilled at each step? How do we demonstrate that our needs are being met? Don't get lost in process details. Systems engineering is simply a good engineering approach that allows us to answer those questions and make those demonstrations as clearly and as timely as possible.
Great, thank you, Rick. It was such a pleasure talking with you today.
Well, I hope you learned as much as I did. Thanks for joining in the conversation and learning more about the systems engineering approach.